In this example, I have a conditional statement that I want to write the converse of, and then I want to check the converse to see if it's also a true statement. And if it is, then I know I have a true biconditional statement, and I want to write that statement here. So let's start off by flipping the hypothesis and conclusion and writing the converse. So if two angles are supplementary, that would be the hypothesis. Then the sum of their measures is 180 degrees. That is the converse. And it's a true statement. So we can write this statement as a biconditional statement. To do that, we don't use the word if and then in the statement. We simply start with a hypothesis. So we're going to write this. We're going to say the sum of the measures of two angles is 180 degrees. Then we're going to insert if and only if. And then we do the conclusion. If the angles are supplementary. So there it is. The sum of the measures of two angles is 180 degrees if and only if the angles are supplementary. And that's a biconditional statement built from the two conditional statements above it. And in the second example, we want to do the opposite. We want to start with a biconditional and this time write two conditional statements. So the first one would be if a ray is an angle bisector, then it divides an angle, misspelled that word there, divides an angle into two, and I'm going to use that symbol instead of writing out the word congruent, angles. That's the first conditional statement. The second one would start with this part as the hypothesis. If, now we're talking about a ray dividing, so we're going to say if a ray divides an angle into two congruent angles, then it is an angle bisector. And that would be the other conditional statement that you can write from the biconditional statement.